Imagine a signal no louder than a whisper racing across the vast, cold emptiness of space. It's not from a nearby star, or even from our own galaxy. This signal has been traveling through the darkness for 8 billion years, before Earth even had continents, before life had formed, before time as we know it began. This message was already in motion, and now it's arrived. Astronomers stared at their instruments, stunned. It wasn't just a random blip. It wasn't interference. This was a fast radio burst, a sudden, intense flash of radio waves lasting just milliseconds, but carrying more energy than our sun emits in days. Short, sharp, and completely unexplainable. They named it FRB 202200610A, a name that sounds almost robotic. But what it represents is something far stranger, a signal from halfway across the visible universe. Now pause for a second. 8 billion years ago, Earth didn't even exist. Our solar system hadn't formed. Yet this signal, this impossible burst of energy, was already heading toward a planet that hadn't yet been born. Is it a cosmic coincidence, or something more? Fast radio bursts, or FRBs, are one of the greatest astronomical mysteries of our time. The first was discovered in 2007, and since then, hundreds more have been detected. Most of them are one-off events, singular, sudden, and gone in an instant. But some repeat. That's right. In 2016, astronomers recorded a repeating FRB. It flashed again and again and again, like a heartbeat in the cosmos. At first, scientists thought it might be an error, a malfunction. But no, it was real. Something out there, billions of light years away, was pulsing. One FRB even appeared to follow a 19-day cycle, repeating like clockwork. Nature rarely works on a strict calendar. Someone was sending signals with precision. But what could possibly produce such a powerful burst? The theories range from the scientific to the mind-bending. Some researchers suggest they come from magnetars, superdense, hypermagnetic neutron stars that erupt with energy when their crusts crack. Others think they may come from the collapse of stars, collisions between black holes, or the aftershocks of supernovae. But none of these theories fully explain the sheer distance, strength, and pattern of these signals, especially repeating ones, which is why the alien hypothesis refuses to die. Now let's be clear, no scientist is claiming definitive proof of extraterrestrial life. But when you receive a millisecond-long signal from 8 billion years away, packed with more energy than a star, it's hard not to ask questions. Could these be interstellar communication pulses? Could a Type 2 or Type 3 civilization far more advanced than us be using focused radio bursts to send signals across galaxies? Consider this. If we on Earth are already capable of sending signals into space, what might a civilization with 1 million years of technological advancement ahead of us be able to do? In 2015, a Harvard physicist and his team suggested that FRBs could be power sources for interstellar spacecraft, massive radio beams pushing solar sails across space, like shining a cosmic flashlight to move a spaceship. Not communication, but propulsion. It sounds like science fiction. But so did landing on the moon, so did black holes, so did radio waves just a few centuries ago. And the strangest part? The signals are still coming. Just last year, another FRB shocked scientists. It originated from a distance farther than ever detected before. 8 billion years of travel. That's over half the age of the entire universe. Let that sink in. When this signal began its journey, the Milky Way was still forming. And now, it has finally reached us, like a bottled message from a ghost ship adrift in time. But here's the kicker. Our telescopes almost missed it. If it hadn't been for a network of synchronized instruments and a stroke of good timing, the signal might have passed us by unnoticed. How many more have we missed? How many are still flying silently past Earth, too fast, too faint for our technology to detect? And what if, one day, we decode one? That's the hope driving researchers to keep watching the skies, to build more sensitive arrays, to listen just a little more closely. Because in the silence of the cosmos, every whisper matters. In a universe where distances are measured in light years and messages take eons to arrive, we may already be part of a conversation that began long before we were here, and might continue long after we're gone. One thing is certain, the universe is talking. The only question is, are we finally ready to listen? Thank you for listening. See you in the next one.